For today is going to be just a basic review of subnetting, segmenting, stuff like that. So the idea is it maybe has been a while since you've had networking, or it's been a while since you've looked at subnet masks, or you never understood it in the first place, or whatever. That's what I'm going for here. Because if you don't get this, the rest of the stuff we do is really, really hard. So that's why we go through a little bit of it. So I guess I apologize if you're like, oh my gosh, we're spending this first class period on subnetting. I know that really well. This is dumb. Well, sometimes that happens, right? So that's, anyway, what we're going to do for today. So we have our series of tubes that all of our internet stuff lives on. Does anyone know the series of tubes reference? No? Oh no. I had to educate my freshmen last semester on this. Not to go political, but the great Senator Ted Stevens has a lovely speech he gave on, I don't even know if it was his support or opposition, I think, to net neutrality. But anyway, he calls the internet like it's a series of tubes. You can tell he doesn't understand what he's talking about. So if you go search on YouTube for there's even a Wikipedia article dedicated to it. Yeah, it's all on your own time, but I do encourage you to go check that out because it's a particular highlight, but it kind of highlights the fact of like the people making the rules for the stuff that, impacts us every day don't have a clue. I mean, it's really what it comes down to. So anyway, when we're talking about our tubes, what layer does the internet live on? It takes a while. Oh, go ahead. Someone say something? No. 3. Okay, yeah, there we go.
Everybody looks back.
Like judging. For some reason, Sid knows. So, as corny as, like, when you went through Networking 1, I'm sure Brent went through his, apple pie shots, taste nasty. What's his other 2? During puking? Okay. Mine was that I learned in high school is all people seem to need data processing, and that's far less fun than Brent's here at DSU. But it was in high school. So either way, as corny as the whole OSI model thing is, because people keep beating it into you, like there's a reason for it. I will say I don't go probably a week in my life without telling someone, no, that's not your problem, wrong layer. Because they'll be sitting there saying, like, I didn't get an IP address, I need to check my whatever. I don't know I need to see if my MAC address is valid, or I don't know what it is. Either way, I'll say something, or I'll basically say to them, like, you not getting to that website doesn't matter because you need to check a lower layer to make sure your link light is on or something. It's usually not that petty. Usually people check that at least. But I don't know. For some reason, I'm stuck with can't find an example. But either way, this whole thing, like, if 3 isn't working, 4, don't even worry about trying to figure it out, right? So we have everything living on our 3rd layer. So when we talk about all of our different networks, we kind of have this, like, mind gap bridge, whatever, of our home network or the DSU network or something is somehow different than the network of the internet. And that's really not the case. It just so happens that your network at home is really lame because it just has one uplink and that's it. Whereas if we look at like DSU, we have lots of different networks here that are all routing independently. We could cut a connection to the network or to the internet here from DSU and we will just reroute. So there's bigger and smaller scales of the internet all going on. And yeah, so getting us out to the internet depends on which layer 3 protocol. What is the one protocol that no matter what, you cannot exist on the internet without? IP, yeah. What's IP stand for? Internet Protocol. Can you exist on the internet without TCP? Can you do internet things without TCP? Yeah, there's other ways, right? You don't have to use TCP on the internet. It'd be weird to not, but based on how we have it set up. But you can live on the internet without higher level protocols. We could exist on the internet without HTTP. We wouldn't have a website to browse to. We'd do something different, but either way. But the one that how about if we go down a layer, if we go to like MAC addresses. If we use something other than MAC addresses at layer 2, could you get on the internet? It's a tricky, like, oddball question to think of. But if we used, instead of MAC addresses, we called them CAT addresses, and it was something totally different, but the next layer up was still IP, could our proprietary network still talk on the internet? Yeah, it could. That's the cool thing about how these layers of OSI model work. Are there protocols out there that don't use MAC addresses that still might exist on the internet somewhere? Yeah. Possibly, yeah.
If there's still ARPANET computers.
ARPANET computers, yeah. There's another one out there called Fiber Channel. It's used mainly for storage, so you wouldn't probably send a lot of it out on the internet, but it doesn't do MAC addresses, and it technically doesn't do IP addresses either, but it doesn't use Ethernet. So by Ethernet, we're not talking about the cord, we're talking about like you plug into the switch, and we all have this little dance with our MAC addresses and stuff like that. Fiber Channel doesn't have any of that. But on a Fiber Channel packet, we can drop it into an IP packet and send it out on the internet. So we can actually exist without the above and below layers, but layer 3 having IP is where it's at for getting there. So what we're going to talk about, or our key thing, is subnetting. So what is a subnet? We talked about it briefly last time. Why do we subnet stuff?
Logically partition networks.
So we need to partition off networks. So if we go all the way into the scale of the internet, like we have the reasons why we subnet here at DSU, don't we? We subnet off stuff because we want to partition things for security reasons. Why security reasons?
To keep like guests and students off of faculty networks.
Yes, the cesspool of the student network, we don't want touching the network I connect to, right? I'm cool with that. Not saying it's a cesspool. Well, I am saying it's a cesspool. So keeping that away, I want that gone. I don't want the guest network interfering with what I'm doing. So there's the security reasons. We don't want you guys to be able to just remote desktop into a domain controller or something like that. So that's a thing. The technical or like the network performance reasons, why do we subnet?
Broadcast domains, you can break them up.
So we want to separate out all these computers doing broadcasts and back to my Windows machines looking for love. So they're going out trying to find friends, and they're sending out broadcasts to do it, and Apple computers do it too. They're looking for love. There's just fewer of them, so you don't see as much of that. So that's why we subnet here at DSU. Why do we subnet on the internet then?
You say white.
Yeah. What's the actual purpose of subnetting when it gets onto the bigger scale?
These countries or certain geographic regions list of IPs.
And we actually even abstracted higher than that. So your IP address, although we do kind of use it to associate a geographic location, isn't necessarily tied to a geographic location. So, because we can move IP addresses around and do all this crazy stuff. Not even for broadcast domains. Because what's cool on the internet, once we're talking about IP stuff going back and forth, the broadcasts domains are sort of non-existent because we're living above like ARP packets and stuff like that, because those are all layer 2 protocols. So when we get out with two routers talking to each other, they could be broadcasting, but they're just to each other. So it's kind of We don't have that many broadcast domains necessarily on the internet. But what we do use it for is somehow the DSU router or the SDN router we handed off to or the mid-continent router we handed off to has to somehow figure out how in the hell to get your packet from here across the country to Netflix or to Amazon or whatever it is. And we kind of take for granted that somehow it just makes it, right? Some way or another. So it's all this big little dance of looking at the math and saying, okay, I own this block of IP addresses. I know which interface to send it out to. I know you own this other block of IP addresses because you told me, and you communicated how many IP addresses you own by using subnet information. So I know if I want to send it to you because you have a closer connection to Amazon than I do, I can send it to you. So it's basically just the magic little math that makes our packets get from point A to point B. Or it takes the decision tree, I suppose, right? How many of you have done routing, configured routers before, if you're a NetSec major? So I assume if you've taken routing and switching, you've written a routing table, right? I hope somehow you didn't magically make it through that class without setting up a routing table. So that's how we decide when a packet hits DSU's edge router, does it need to go out this link or this link, right? Based on those routes. So when we look at the math or the subnetting inside of our IP address, we have a fun little history based on how we subnet stuff. So has anyone heard the term like, oh, you're using a Class C IP block? Or a class DSU owns a Class B, right? So this is turning us back into our history lesson, why we use those sort of words. Because they don't actually exist. We don't really use that anymore, but we still say the term Class B, Class C. Does anyone know why? I actually have a list of the classes first. So like DSU has a Class B address. As you know, all of our IP addresses start with 138, so what do you know? We fall inside of that range. So someone can own a Class A address. So if we go back to, well, there's two other classes too, D and E. Does anyone know what multicast is?
Broadcast with specific computers, multiple specific computers.
Yeah. So if you go somewhere that's using IPTV stuff, like if you go into a hotel and you look in the back of your TV and there's not coax coming into it, there's just a network cable plugging into the TV or the box or something like that, that's doing some sort of IPTV. So your hotel, or I guess in my personal experience, it was a stadium that I worked on doing an install for a company I worked for, was delivering like 100 and some channels of 1080p content. So does 1080p take a lot of bandwidth? Decent amount. So if we delivered 100 channels of that to every TV, and there's 300 suites or 300 TVs or whatever in that building, and it's just a gigabit network, can that handle 100 times 300 over a gigabit? No. So what multicast then does is the TV, when you actually change to channel 3, you would join the channel 3 multicast group. So we would have our source device sending out all 100 channels. It would send it to the router or the switch, depending on how it was set up, will probably same difference. The switch would understand all of these TVs are subscribed to this channel, so I'm just going to send the channel 3 content to those IP addresses. That way our device that sent out all the TV channels didn't have to send out multiple copies of channel 3 to each one. We just send out one, and then the routers actually duplicate the packets for us. There's another spot where multicast is used in sort of help desky deploying computers. You know what that is? Yeah, imaging computers. So if I was going to image the hard drive on all of your computers, my server that has the hard drive image on it could send out 30 copies of every byte of that hard drive image for all of you, and that would work. But say I have a 10 gig hard drive image, so I'm sending out, 300 gigs of traffic on the network? What if I just sent out the 10 gig image and then the router just knew to copy the packet itself? So that's what multicast does for us. So it gets weird. Anyway, that's where you get Class D addresses from. So when someone talks about multicast stuff, that's what they're doing. They're just being really, really efficient with how they send out traffic. And multicast addresses fall inside of this range. Then you should never see a Class E address used anywhere on the internet. But there's not huge, but a decent block of addresses on Class E that are just for, like, the places you should see them is actually in routing and switching when you're configuring a fake WAN interface or a fake router, stuff like that. That's where the Class E addresses are supposed to be used. So, coming back to this list, this is classful subnetting. So if we go back into, like, I don't know, someone earlier said something about ARPANET, like back in the good old days, or more so like pre-1993. If you were a business, how do we do IP addresses in your house now versus what we would have done, assuming you would have had an internet connection in 1990 in your house, which you wouldn't have, but either way. Let's pretend. How do we do it differently now versus back then?
Way back when you didn't have DHCP, if I remember correctly, you uploaded your address to like a central server, and then everybody would update that by taking that text file.
Oh, you're going way, way back machine there, aren't you? So, how many IP addresses on the internet do you have at home? You have one. If we go back to like 1990, and let's say the DSU is a bad example. Let's say the print shop down the street needs an internet connection, and in addition to their internet connection, or on their internet connection, they've got printers and a computer and all this great stuff. How many IP addresses does that company need?
A 4NAT?
Yes, because this is pre-NAT.
And then you need one for every device.
You need a public IP address for every single device. And you would have a router sitting there that understood all of these IP addresses belong to you. The tricky bit comes with the print shop down the street. We needed to give them an address for every device, but we still had to make sure the routing worked. So, how many addresses would we give the print shop down the street? Any guesses?
The smallest possible chunks.
We would give them the smallest possible chunk. What was the smallest possible chunk we could give? Is a Class C. That's the smallest chunk of addresses we had. So that's why we don't use this system anymore. You could have, if you were a business that had 20 devices that needed to be on the internet, the smallest number of IP addresses we could give you is 254. We didn't have a way to give smaller blocks of addresses. Then comes the next fun thing. So, like, let's take DSU, for example. We enter the picture and say, well, we need more than 250 addresses. So what's the next step up? 65,000. Do we need 65,000? No, not in the least bit. Like, you go talk to folks in the IT department, and they tell lies. Well, we need them all. And then I'm like, really, guys? And they're like, well, no. We just don't want to be accused of having to give them up. I'm like, no, that's fine. Keep them. It's not our fault that no one else got IP addresses when they should have. So they can feel the burn, right? So what would we say? DSU, if we were going to have all of our devices on the internet, needs, what, 3,000 IP addresses? But that would be a lot. That'd be 10, 15 little 254 blocks. So we got a Class B. And then let's say you're a really, really big company that needed more than 65,000. Well, then our next thing was to give you 16 million, right? So overkill in a little bit, right? So why does this system suck, and why do we not use it? Because it sucks.
So obviously, people who don't need 65,000 networks that have more than 254.
Yeah. Well, what if we could, happy medium, right? So nowadays, like the IA lab, for example, has a mid-continent internet connection. And I called mid-continent and said, I need a block of public IP addresses. They didn't give me 254. They gave me, drum roll, 4. because I even was struggling to get them to give me 4. So why did we decide this system was terrible? In the end, in the long run. Yeah. Like even back in 1993, I think. I have it on a thing. Yeah. In and around 1993, the world started to realize, like, oh no, this whole internet thing's actually catching on. We made this allocation model really stupid. So then we created a new system, which we'll talk about. Even today, though, there are still a bunch of Class A IP block holders. So Department of Defense has a bunch. And then there's fun ones like, I don't know why Ford, but they have a Class A block of IP addresses. Maybe they're doing a bunch of stuff, for all I know. But when you think about the Class A holders, they're really not interested in giving them up, right? But
couldn't we have advertised like the Class B here, just outpost networks, since we're separate AS, and using it for description?
say that again?
Couldn't you have advertised our AS outpost content and SDN rather than having separate IP addresses?
Oh, for me? I wanted something entirely separate, and Midco wasn't interested in taking BGP updates from me. That's basically what it comes down to. Yeah. But yes, I could have talked to Midco and done all of that, but the idea was to have a totally separate DSU connection. The one reason being, in our case, which we'll actually talk about in class, we will talk about honeypots and stuff like that. So every once in a while we'll run a honeypot on there, which when someone looks up information on that IP address, they're like, oh, it's just a Midco IP, okay. As opposed to when you run a honeypot off of an IP address that's clearly owned by a university, and then someone that wants to, nudge the machine a little bit, looks up the IP address and sees, oh, it's a university, and then they look at dsu.edu and they're like, oh, they do security stuff. So then they say, I haven't found grandma connecting her old Windows XP computer to the internet. I found someone that's screwing with me. And then we don't get a lot of love to our honeypot. So that's the kind of short and sweet as to why we went off onto our own little thing. So classful stuff was neat back in the day. Now we do CIDR stuff. So what's the big purpose of doing CIDR notation when we're subnetting stuff? When we're segmenting out our networks? What's the problem with classful? It's inefficient because how many categories do we have? We got 3. How many categories would we like to have? More than 3, right? So that's where we come into classless. So when we see CIDR notation, where you see a WAC 24, where do we get that number from? Any guesses as to where the 24 comes from? It is the 24th segmentation that we can do. So how many different, instead of 3, with CIDR notation, how many different subnet sizes can we make now? We can, technically we can make 32, but yeah, realistically you'd make 30 because you're not going to make a 0 IP subnet or a subnet full of every IP address in existence. So neither of those, well actually you do use the slant 0 quite a bit. But when we're writing about a subnet mask, so we have our subnet mask 255.255.255.0, and that's a slant 24, where does the 24 come from? Yeah, when we convert 255.255.255.0 into binary, which looks like this, 8 ones, 8 ones, 8 ones, what's 8 plus 8 plus 8? 24, yeah. So that's where that comes from. So when we do these, there's the 3 classes of IP addresses, but then we can do crazy other stuff in between too, and life is really awesome. If I am at my house, which actually I guess I don't use that block at home, but I want to tell you about the subnet that I use at home, or the IP scheme I use, I can tell you 192.168.1.0/24, and you now know what IP addresses are all valid on my network. Should be all these, right? 1.1 through .254, right? Or technically 255. What's 255? What's the IP address right over here? That's the broadcast address. What does the broadcast address do if I ping that? It actually, it depends. It doesn't, it's supposed to send it out to everyone, and everyone is then supposed to reply. What result you'll find is some things reply. So if you actually go somewhere, like go to your house, assuming you have a house or apartment or whatever, little experiment and ping your broadcast address, keeping in mind like Windows firewall defaults don't allow ping and all that great stuff, but assuming you have devices that will ping, you will notice some of them actually do ping or do actually reply. So it's kind of cool to ping out one IP address, and then when you look and you notice when you do ping, you get like ping, I'll just say google.com. I get reply from, which say let's go take the example even further. Make this bigger, ping that address. Okay, so I just typed in that IP address. Isn't it really stupid then that it says, I got a reply from this IP address? And you're like, who knew? Because that's the one I typed in, right? I kind of expected to get a reply from that one. But you can actually ping the broadcast address and get replies from other devices. So it's a really sleuthy way to figure out devices on a network. Also, it's a good way to find like malware on someone's computer, because if you have the secretary's computer is all of a sudden pinging the broadcast address, they're phishing for devices. So, anywho. So this comes to a pet peeve of mine. By the time you are at this stage in life, you have to know the difference between a / and a \. It's unacceptable if you don't. It's no good. I will lose my mind if you send me an email and saying, well, I'm trying to configure these IP addresses and you use the wrong /, or I'm hoping at this stage in life when there's a commercial on TV and then they read their website, like, go to dsu.edu /apply now or something like that. And then they put the link on the screen and it's a / because that's what websites use are /. I like instantly lose all credibility without whatever like marketing place made that ad, right? So, or when it seems like, I don't know if it's just something that sounds cool if you're a radio announcer, but they always say / on websites. So remember that the / he falls over backwards onto his back. The / is going forward. So when you look at your keyboard, the / is falling over, the / is going ahead. Or if that's too much, just write / on your question mark key and just be done with it. That if you can't handle that. So very, very important to know all of these things. So when it comes down to subnetting and the subnet mask and the CIDR notation, what would be the CIDR notation for this instead of writing 255.255.255.0? Yeah, instead of saying, because it sounds dumb for me to stand here and say 255.255.255.0, instead we can just say, usually they say /24 instead of /. So that gets even more fun lingo, right? So instead we would say /24 for both of these. Can these computers talk to each other directly? Yes. So, I thought I had changed the order of these. Okay. So this is, yes. So the idea that what our subnet mask is doing is it's specifying what part of the IP address is being used as a subnet and what part of the IP address is just being used to identify your computer on the network. So in the easy case of a /24, these first 3, what are the individual blocks of numbers called in an IP address? Octets. Why are they called octets? because there's 8 tets in there or something. Yeah, there's 8 bits in there, or bytes in there. So we have the first 3 octets are all 1s. Therefore, these two have to match for these addresses to be the same subnet. Meanwhile, these over here are just identifying different computers. So can they talk to each other? Yeah. If we go back to this one now, notice the subtle difference, and I had it out of order. Can these two computers talk directly to each other? No. Because when we have a slant 24, this third octet is different than this octet. Mathematically, these computers can't talk. So what will actually happen when you try to talk to each other is their network adapters are just going to ignore each other. So then in this case, what if we change the subnet mask to be a slant, what would this be? Slant 16. So therefore, we're only worried about the first 2 octets. Can they talk to each other? Yeah, they can. Because now, when we switch to binary, what in the world? Oh, yes. Wow. So it's cool when I do these fun examples like this. But then when we start throwing binary in, I have this crap out of order. That should go there. This one should go there. It's again why you guys are the test class. That way for the afternoon class, everything looks perfect, right? And I don't know why I record this one, because I'd look way smarter if I recorded the afternoon one. I must not have done the other one in binary, which that's fine. Okay, so these two computers can't talk. If we look, there is a subtle difference in these 2 network addresses, because this one just is a 1, or this bit is on, whereas these bits don't match. Therefore, those 2 IP addresses can't communicate with each other. They're on different subnets. How about, we just talked about this one, they can, because we just moved it over. How about here? Can these 2 computers talk to each other? This is weird and you'd never do this, but this is more like the trivia question. This is the question that a textbook would have on the test, but I would not, because this is a stupid question.
Maybe so. Maybe computer 1 is like a subnet of computer 2.
Yeah, so one computer can talk to the other, but it's not really aware that it can, I guess. But the one, what would say, computer 2 can probably send a packet to computer 1. When computer 1 goes to reply, the network adapter is just going to be like, I can't do that, even though it just received a packet. So that becomes the fun in routing and firewalling. We can have instances where, like, if you're pinging and you're like, the ping's not working, I'm not letting the traffic in. You can actually find instances where, like, if you run Wireshark on what you're pinging, you'll actually see the ping packet come in. It's just for some reason the reply is not getting back out. So that's oftentimes a subnetting and a routing problem, or a firewall problem, which we'll come back to. So this comes back to our logical thing. What do you need then if you want 2 computers to talk to each other that are on different subnets? A router. So this is also where technically subnetting is just a logical subdivision. It should also be enforced as a physical subdivision. But could we all plug into the same switch and configure our own subnets and just talk to each other? Yeah, will my computer see your traffic if you're on a different subnet if we're all on the same switch? Possibly, yeah. So the logical thing comes back to our good old days of using hubs, to where technically you had to physically separate your subnets as well. Whereas now we really don't. So yeah, we just said routers do that, blah, blah, blah. Oh yeah, that was my hubs thing. There's something else I wanted. Here we go. When you are configuring a network interface, then, one question that they will always ask you is, what's your default gateway? So what is that IP address you put in for default gateway?
That's usually the first address available.
It is usually the first address available. So if our subnet is something like 192.168.1.0. What will we probably use for a default gateway? .1. More critical is what is a default gateway? This is a Windows term as well, by the way. Other operating systems, I don't believe, use the word default gateway. I'll check and then eat my words and be wrong again. Yeah, they don't. So Windows term, what is the default gateway? Who owns that IP address? Why do we put that IP address in there? It's your router, yeah. Like when we look at everything that's not Windows, usually they're not going to ask you for a default gateway because that is a stupid word Microsoft just dreamt up because they're like, hey, you know, we could call it a router like everyone else does, but instead, let's come up with something totally arbitrary and different. So then that's, you know, in the mind of Bill, that was the way to do it. So anyway, Linux, Mac OS, like everything but Windows, when you're configuring your network interface, it's going to ask for a router, which makes way more sense. So that comes back to, do these two computers need a default gateway or a router to talk to each other?
Not these,
Why don't they?
because they're on the same network.
They are on the same network. When we look at, if we convert this all into binary, but we don't need to because they're 255, which we know means the whole thing's lit up, the network portion of the address, the first three parts of the address, both match. So when these two computers talk to each other, what is the only bit of hardware on the network that they're going to interact with? The switch, yeah. So they're just going to touch the switch. Will the router, or in this case, if we have a firewall that is firewalling the network, will the firewall know anything about these two computers talking? Won't know a single thing about it. So this will come back to play in the world of firewalling, because why do we want to fire? What's the firewall doing for us in the end? What's its real purpose?
Screening packets.
To filter, stream, make sure, like, be the gatekeeper, right? You're allowed to talk, you're not allowed to talk. Is there a single reason in the world why any of your laptops in this room would talk to each other? Unless you're playing like a LAN gaming with each other. Or we just go to like the business network, so to speak. Is there any reason for any two people's desktop computers on a subnet to talk to each other?
Maybe transfer files.
Maybe, but what in a business are you probably going to use?
Windows has its peer-to-peer update.
Oh, and thank God for that. Yeah, so Windows 10 now does effectively BitTorrenting updates to each other. Not specifically BitTorrent, Microsoft ripped it off, but yeah, so instead of like when you go to do Windows updates on Windows 10, instead of you just going out to Microsoft or wherever their cache is and getting your updates, Windows looks for love and looks for other Windows computers to source its updates from that are nearby. So for your computer at home, makes sense if you take your laptop there that's perfectly updated and has all the updates, and then you have your desktop that's behind. Makes sense for your desktop to try to get it from your laptop, I guess. I'm just hoping that there's going to be a field day with someone compromising and sending out fake updates that way. But either way, the model of that just sounds dumb. Inside of a business, even for Windows updates, where are we probably going to get our Windows updates from? We probably have a Windows update server that's caching all of them for us. So we've already overcome that. So still comes back to, can you think of a reason why any two people's computers need to talk to each other? Ever? No. There's really not. At home, sure. My phone needs to be able to talk to my Apple TV because I want to listen to music through the speakers in my living room. But my Apple TV doesn't do Spotify. I have to use the app on my phone, so I have two devices that need to talk to each other. That's one instance. But two computers at a network or at a business? Not really. But can we filter them? Do Do we have, can the firewall do anything about these two computers talking to each other? Can't do a single thing, right? Because the firewall is only going to interact with these two computers when they're leaving their subnet. So in this case, would the firewall filter communications here? Or going back to the simpler thing, do these ones need a default gateway configured and running in order to talk to each other? Yes, they do, because we have two subnets talking. So could we firewall these two machines from each other? Yeah, we could. So when we are playing with IP addresses, we have a general expectation, generally speaking, and we said it before, what's the address you're going to use as your default gateway?
First available.
Probably your first available, yeah. Why would you do that?
You got to put it somewhere, and that's when everybody's going to remember it.
Yes. That is the, 99% of the world uses the first address because it's just what you do. It's just easier, and it makes sense. There are people that want to watch the world burn that will put it at, the last usable IP address I've seen before in a couple places where they just were they had this thing of well, it's secure, no one can guess our router. And I'm like, yeah, but your DHCP server's just handing it out. So I could probably figure it out pretty quick. So there's that. And then there's some, I don't know what they were doing, but they picked no, we use the middle. I have one instance where they use the middle IP for some weird reason. And I just kind of had this okay, I have nothing for you here because your level of doing weird crap is just so amazing. So instead of converting all these things to binary and whatnot, what is a better way of figuring out what our default gateways or our subnets would be? You could Google the CIDR chart, yes. That's foolishly small. And well, close enough. So we could do that. And that kind of gets us, it gets us started anyway. What will using the CIDR chart make, what would we say, difficult for us? It's easy when we're down here in the really big ones. But when we get up here, let's say, well, yeah, we can use this one. Let's even go further. Slant 29. What's the default gateway of this one going to be? What do we have to do in order to figure that out using the chart? You could divide 45 by 8, yes. I was going for the more automated solution than just figuring out the math by it. I'm surprised this didn't come. Has anyone used a subnet calculator before? Okay, I'm starting to get worried that no one was saying, just go to a calculator and fill it out and let it do it. That was what I was expecting to come up. Maybe you were all expecting something more grand or complicated or something. No, just go to a calculator and just do it, right? So 192, 10, 45. Oh gosh, no, this is the stupid one. Because this is a slant 29, but this one I don't think takes. Nope. Do we have to hit calculate first? Then say 28? See, watch. Now what you've done in class today is watch me struggle with a subnet calculator. This is the crappy one. So it's subnetcalculator.com. This is the one Tullis uses, isn't it? Oh. There we go. So Now, granted, this one doesn't specifically say CIDR notation. It asks for the number of bits in your subnet mask, but same difference, right? So when we get our subnet ID, what is the purpose of that IP address? Yeah, it's like the roving equivalent of like the name of the network that you can associate it by. Can you use this IP address for anything? No. So the .32, technically, by the way, we made this system, for every time you subnet, it automatically burns 2 IP addresses from you using. But it was better than burning, 60,000 IP addresses every time we subnetted. So what's the first usable, what's the default gateway probably going to be on this particular subnet? Oh, I did it wrong. I picked the wrong one. Jeez. The struggle is real today. What's the default gateway probably going to be? Probably 41, yeah. So I'm going to skip talking about how consumer routers are evil, I think. The other stuff, well, I made things, and I'm like, I don't want to go through. Yeah, we're just going to probably stop there. We've had enough fun for today. What's that?
Almost as evil.
Where was that? Is that the Xbox? Yeah. Yeah. Well, I'll talk about, so how many of you have a consumer router at home? I assume almost all of you, right? How many of you have some sort of thing you play online, like an Xbox or a PlayStation or something like that? Yeah. How many of you went and opened up the ports to the internet for your Xbox to work? Yeah. That's why this device is evil, because you didn't, right? Any idea who did open the ports in your firewall?
Me.
Well, if you did it manually, that's cool. So these devices support a fun protocol called UPnP, Universal Plug and Play. And what the point is your Xbox isn't always just sending packets out. Sometimes it needs unsolicited packets to come in. So you need to have your firewall just open, letting traffic come in and stream to your Xbox. So I would be willing to say that 99% of the people that buy an Xbox are not apt at properly configuring their firewall to let traffic into the Xbox correctly. So what we did, and we all love this, is we made this protocol where anything on your network can just be like, open up a port on the firewall for me and forward all the traffic from the internet to me. And thank God Java and Flash both implemented it too. So that's why all of these things are perfect. So that's our universal plug and play is a very, very bad deal. Because it's nice because it lets your Xbox configure the firewall settings that are appropriate. It's also complicated because it makes, when you take like an Xbox to a big network like DSU, it's really, really, really hard to get them to work. Because our firewall does not just open up ports as deemed appropriately by the devices of the network, right? So there's some, a little extra love needs to be sprinkled there. But UPnP, which if you search through your router's configuration page at home, if you have an Xbox or PlayStation that just works on the internet, if you search through there, you're going to find that you have, depending on the kind of router, it depends on if it's a router that wants people to tinker with it or not. It might say like UPnP enabled, or it might be like allow devices to configure your network firewall. It might not explicitly say UPnP, but either way, it's probably turned on and letting stuff come through on your network. So there's that. That also, another reason why these devices are evil is we have gotten used to how these kind of do everything for us. Because when we say the term wireless router, that's actually a broken term. This is a router that has a switch and a wireless access point all soldered into the same board, put inside of a cute-looking plastic case. So the problem with these is they're meant to be consumer-friendly, right? So if your understanding of firewalling is based on this, that's cool because it's a real firewall. When we come in to do stuff for our class, it's going to be way more difficult than configuring this, because this is just doing stuff for you in the background. Mainly all of the NAT sort of stuff. So that'll will come back to play. The other cool thing or interesting thing with this is, like, not that we would, but DSU having public IP addresses inside of our network, like, that device couldn't do that. That device can only be used in home environments where you only have one IP address. So that's just to set the stage of things to come, in essence. Yes, because it does NAT and all that good stuff. But we're going to talk about NAT later on. So that's where I'll stop. Now, the next little nugget that I have is there is now an assignment posted in D2L, and there should be virtual machines pushed out. So in this assignment, whoops, didn't want that. There we go. We'll open this up. What you have is 4 computers and a router. The router is configured already. What you have to do is, using a subnet calculator or doing it by hand or whatever, figure out the default gateway or the router for all of these machines and make sure that they can all talk to each other. So when we have, for example, this one's really easy. Basically, all you're doing in this lab is configuring the IP address settings on all 4 of these computers. So this one, I'll give you a big hint. What's its default gateway going to be? .1. How do you know it's .1? Because slant 24 is one that we should just know. That just means the 1, 2, 3 are all the network address, and then it's a .1 after that. So, yeah. So what you get to do is pop into each machine, configure the IP address settings in them that are appropriate, and then ping across the network and make sure that they're all working. And that's actually all your screenshot is just showing that, like, yep, I can ping the other device. Keep in mind, Windows has a firewall on it. So is anyone, or how would we say, have we configured the Windows firewall before to either allow ping, or what's your more default answer? Just disabling it, yeah. Which there we go, security tip 101 for the day. In your homework, if you can't get it to work, just turn off the firewall. But I guess in the case of this, that's fine if you just go turn off the Windows firewall. I'm not going to know. So you'll have 1, 2, 3, 4 screenshots, and then I don't have a screenshot standards doc, but make your screenshots so I can see them. So if you have like a 4 monitor array hooked up, and you do a screenshot of the VM that's minimized and like the 3rd display over, and then you paste the thing over with all 4 monitors all zooming across, that's really hard for me to go through, because then I have to go into Word and start cropping things down. And if you also want to make my day, I really like stuff submitted as PDF, because then I can just open it and do it better rather than having to wait for Word to grind up to a running start and open times like 90. So those are my little requests. But anyway, any questions on this lab?
The PF box already has all the interfaces configured with the first available address on the network.
Yes, the PFSense box is pre-configured already, or your router is pre-configured, and it is password protected, so you can't get into it and just look. And you don't need to get into it. Even if you could, I don't have the slightest idea what password I put on it, because I've already since forgotten. But yeah. So the firewall or the router will allow all the traffic through, and there won't be any filtering blocking inside of that. So, because that would be a dirty trick, wouldn't it? Any other questions? Also, you get 10 points for showing me a screenshot that you shut your machines off when you're done. Thumbs up for that. I'm going for hoping to, what would we say, manage resources of the IA lab a little more efficiently.
You're just showing them the shutdown stage?
Honestly, yeah. It seriously is just taking a screenshot, being like, "Yep, they're off." That's it. So,
Now we're back on.
yeah. So, all right. So that's what I've got for today. Also, as a potential FYI, there may be a iLab interruption on Saturday morning, which I think Brent sent out an email at a ripe 2 a.m. or something like that. But DSU is changing around our edge router, and we're potentially moving the iLab's firewall uplink to a faster interface. Maybe not. So anyway, potential that may be going on. So FYI.